All right, so let's say your teacher said, graph these rational functions. Just make a graph of them. What should you do? Well, hopefully you're looking at what you've been taught before with vertical asymptotes, the domain, possibly the X and Y intercepts. Let's just write all those down for this first one. So let's look at this. The domain. Domain is going to be all the numbers except for the ones that make the denominator 0. So it looks like we're going to have 1. And then we look at vertical asymptotes. So the vertical asymptote is going to be at x equals 1. Why? Because that makes the denominator 0 and that factor is not repeated up top. So at x equals 1, we don't have a value here. And in the rational functions, it's going to create an asymptote. All right, what if I wanted to look at the X-intercepts? So the X-intercept would be when we have an x value and 0 for y. So what we did, I'm trying to separate these a little bit. So what we did is we plugged in 0 for where the output would be. So 0 equals 1 over x minus 1 squared. So you're following what your teacher told you and you're saying, all right, cool, I'm going to find the X-intercept. So we multiply both sides times the denominator. When I do that, get x minus 1 squared. This will cancel. 0 times x minus 1 squared. 0 times this is 0. So that's going to be 0 equals what's left over on the numerator? 1. What the heck? 0 equals 1? What the heck is that? Well, it turns out you just discovered kind of something else that's breaking right here. We also have another asymptote that is not just vertical. There's a horizontal asymptote, and that means this is actually on the x-axis. There's a horizontal asymptote here. So this can happen, right? 0 cannot equal 1, or else the universe starts caving in on itself, right? So we have another horizontal asymptote. So this is going to mean horizontal asymptote. And you're not going to have to do this every time to find a horizontal asymptote. There's a shortcut when investigating rational functions to finding horizontal asymptotes. But I just wanted to point that out. You're graphing this rational function, you might be trying to find an x-intercept and getting some crazy answer. Some of you might have just gone, oh, it's just 1, because, you know, just set it equal to 1. Maybe you just didn't realize what the actual math was. But there's a horizontal asymptote there along the x-axis. All right, so now we're ready to make a graph. I want to make a graph of this. I want to draw that one to scale. All right, now I have a graph. So what I want to do is I want to use my information, the vertical asymptote at x equals 1, and I want to put that on the graph. So at x equals 1, I'm going to put a vertical line here. I'm going to use a pen to do that and show my vertical line here, my dotted line to show what the graph cannot equal and what it approaches but never gets to. All right, so then I can't use my x-intercept, right? I can't use my x-intercept. I could figure out my y-intercept, and what I'm going to do to figure out not only my y-intercept, but a bunch of other values is I'm going to make an xy table here. I've actually suggested doing that before in the past, is plug in values for x and get the outputs. So when x is 0, what happens? Well, looking at my original equation, I've got actually expression, I guess I should say. When x is 0, 0 minus 1 is negative 1, squared is 1. So my output then would be 1. When x is 0, my output is 1. So there's 1 point on the graph. What happens when x is 1? Well, we don't have a value there. It won't work. We'd have 0 in the denominator, no output. What happens when x is 2? So I'd have 1 over 2 minus 1, which is 1, squared is 1. So I get 1 again, right? So when x is 2, I get 1. What happens when x is 3? If I were like way out here, came out here to 3. Well, I plug in 3 there, I get 1 over 3 minus 1. 1 over 3 minus 1 is 2. 2 squared is 4. So that's what, 1/4? 1/4. Okay, so 3, it's 1/4. Here's 1, so that's a half. This must be 1/4 right there. And I'm starting to see what the graph looks like, right? So now I'm starting to see, oh, the graph must go something like this. Because before we had those points, we didn't know. Maybe it approached it and went down this way. We know we can't touch the x-axis. We kind of showed that because we have this horizontal asymptote. So there's this dotted line here too that's along the x-axis. We can't get any output values there. And it turns out I'm not going to be able to get any output values that are less than 0 anyway, or equal to 0, because my denominator is squared. So anything I plug in here, any x value I plug in, and I subtract 1 from it, no matter if that's positive or negative, I square it so the whole thing becomes positive. I'm going to have nothing but positive outputs in this situation. So it's going to be, actually it turns out to be that it's going to be symmetrical. I can check what happens at -1. At -1 I get 1/4 as well. So -1 I get 1/4 as well. And it looks the exact same, but it's not symmetrical around the y-axis or anything. So it's not an even function or anything. It looks like it would be, but it's shifted over to the right one. That's exactly what my graph looks like. Those are all like the critical features. You could add a whole bunch of points there, and you can also check that in your graphing calculator. You could go through this and do 1 over x minus 1 squared, and you could look at the graph to kind of look at it, but it's like, oh, I'm not sure if that works. You could also look at the table. So the table's right there. If you hit the second button and then this, you can look at all the x values. Now my table is messed up, so I need to reset it. I'm going to go to Window, except right above Window there's a little yellow key. So I'm going to hit second, then Window, and it says Table Start. I want my table to start at 1. And this says Change in Table. What do I want the table to change by? I'm actually going to do 0.25, just so I can see how it's changing from, instead of jumping from 0 to 2 to 3, I'm going to see how it changes this way. So at x equals 0, we have 1. At x equals 2, you can see it, what happens when x equals 1, we get an error. At x equals 2, I got 1. At x equals 3, I got 0.25, or 1/4. And you could check all these, right? So what happens when x values get really, really big? I get really, really close to the x-axis, really, really close, but I never quite get there. And you can scroll up, you can scroll the other way, and the same type of thing happens. When I scroll to the negative direction, I get negative values as well. What you should do is, if you're trying to learn from this video, is use your graphing calculator as well, but only do that to verify your answer. So this other example right here, try that one on your own, and when you're done, unpause the video and see if you got it.
Alright, let's see if you got it. You should have done a bunch of different things. So I'm going to speed up the video and it'll reveal the answer. Alright, so you should have gotten this vertical asymptote here. There's also another horizontal asymptote right there. And if you put on the little XY table, you can test some of these points. Normally you're going to want to test a few different points around here, so I could have tested out -4. -4 plus 2 would have been, -2 squared would have been 1/4. So we're going to 1/4 way over here. So that would have been that value. And that would be it. Hopefully that helps. Good luck.